Hello, everyone. Welcome once again to today's lesson. And in today's lesson, we are going to look at the continuation of the application of word differentiation. Okay, we will be looking at the second application. The first one, we looked at finding the gradient of curves at a point. And remember, we said that the gradient of curves at a point will be the same as the gradient of the tangent at that particular point. Okay, that was our major pick from there. We said that the gradient will be the same as dy dx. Okay, and whenever we mention gradients, you should know that anytime we are talking about gradients, okay, something should click. That usually, okay, we'll be dealing with equations because you can use gradient to find equations of what? Of lines. So that moves us into our second application. But before the second application, please, if you are here to subscribe to my YouTube channel, okay, do so, subscribe, like, and share, and comment where, okay, necessary. Please take notes. We'll be dealing with tangent and normal, finding the equations of what? Tangent and normal as our second application. So by the end of today's lesson or this particular lesson, you should know how to identify tangents and normals to a curve, and also how to find their equations. Remember, tangents and normals are lines. So, and you know the basic formula for finding, equation of a line. If you know that, we are so good to go. Okay, so how do we identify tangents and what? And normal. Okay, so this is it. As for tangent, when I introduced you to the gradient, I made you aware. We know tangent basically will be any line drawn to meet your curve at exactly one point. So assuming maybe this is my y-axis, this is my x, I'm using a free hand. Okay, and I have my curve, assuming this is my curve. Let me use a quadratic curve. Okay, at this point, I can find the tangent, here. So that will be a line drawn to pass through that point, cutting my curve at exactly one point. So this becomes my tangent. And the normal, basically will be any line that the normal, to a curve at a point, will be any line that meets the tangent, at that point at an angle of 90. So any line that is perpendicular to the tangent at that point, will be what we call the normal. So if this point, I draw a line to meet this, tangent, line, this line is what we call the normal. So normal indirectly is another, term for perpendicular line. Is that clear? But it's always perpendicular to a special line, which is what? The tangent. If the line is not a tangent, we don't call it normal. Is that clear?
Yes, please.
Okay, and like I said, these two are lines, and we know how to find equations of lines. Remember last vacation, we did the coordinate geometry one, everything about lines which we know now. Okay, so this is what we need to know. So let's go and look at how to find the equations of what? Tangents and normals to a curve. So the equation of a tangent to a curve at a point A, x sub 1 with its coordinate, s coordinate being s sub 1, y coordinate being y sub 1, is given by this. Y minus y sub 1 is equal to m into x minus x sub 1. You know this formula, right? The equation of a line formula.
Yes, please.
The points, slow form. Where m is the gradient of the tangent. So far, dy dx that you were finding, when you were finding the gradient, of a curve at a point, remember, we're using dy dx. So that's dy dx, which happens to be the gradient. We said that is the gradient of what? The tangent. So if you know how to find the gradient of curves at a point, then it means you know how to find the gradient, to the gradient of the tangent at that point, because the two are the same. So take note. Then remember that we said the normal and tangents are perpendicular. So remember when we were doing the coordinate geometry one, we said if you have a line y is equal to with this formula, y minus y1 is equal to, okay, m into x minus x1, then the equation of the perpendicular line, okay, perpendicular line, okay, that one will give us y minus y1 is equal to what? Okay, minus 1 over m into x minus x1. Do you remember? Because the gradient of the perpendicular line will be, okay, the negative reciprocal of the gradient of the line itself. So if the gradient of the line is m, then the gradient of the perpendicular line, okay, will be negative reciprocal. So it will be negative 1 over m. Because the product of the two gradients should give you negative 1. Remember, we said the gradient of what? A line and the perpendicular line. So the m1 times m2, okay, should always give us negative 1. Okay, so if you know one, you know the other. Is my point well made, my professors?
Yes, please.
And I told you that anytime you are quoting the equation of a perpendicular line, you always quote this. And that is the main reason why you have this here. Realize that we said the normal is a perpendicular line, but perpendicular to your tangent. So its equation will be given by this, where again, the m here is the gradient of the tangent. So you find the gradient of the tangent. Once you know the gradient of the tangent, you go and substitute the x coordinate and the y coordinate. So here I'm assuming, based on the diagram, I'm assuming the point of intersection here is A with the coordinates, okay, x sub 1, okay, y sub 1. If you want to find the gradient of any line, we need, okay, these two basic information. Remember in our coordinate geometry 1, the gradient and what? And the point on the line. Are you with me? Hello, my professors, are you with me?
Yes.
Yes,
Okay, so
please.
okay, so now let's take this note. I think I've even said it in my presentation. The normal to a curve at a point is the line perpendicular to the tangent at that point. So that is what you have in that picture. So indirectly, I've said it, and now you have it in your notes as well. So let's go and look at how best we can make use of this information, okay, in dealing with what? The worked example that we have, okay, next. Okay, so let's look at our first worked example. Okay, so find the equation of the equations of the tangent. So we are finding equation of the tangent and normal, okay, to the following curves at the indicated points. Okay, so let's go and see, okay, what comes in. Okay, if you're able to do this first one, okay, and you run out of time, okay, that will be fine. At least I want to build your foundation so that in our next meeting, it will be so good to go. Okay, so after reading the question and underlining the salient part, the next thing that we write will be solution, then the major question number. Okay, minor question number A. Okay, so we are finding the equation, okay, of the tangent and normal to this curve at this point. So the curve is very important. So y is equal to, we are given y is equal to 3x cubed, okay, minus what? 5x squared. Okay, then plus what? 3x, okay, plus 1. Okay, at this point, so you can underline the point. We'll extract it at a way. Or if you still want to extract, you can extract and what? 1, 3. But remember, per what you've been doing, I said, okay, we'll extract it at a point, so you can choose not to underline. Or extract it at the preliminary stage. So now let's see. Okay, we are asked to find equation of a line. And I know the equation of a line, okay, will involve what? Gradient, is that not it?
Yes, please.
Okay, so what I'm going to do is I'm going to write maybe equation of normal. So let's start with the tangent first. Equation of what? Tangent. I know is given by y minus what? y1 is equal to m into x minus x1. If you have space, you come and continue here. Is that clear? I realize that it won't go there. That's why I came down. Is my point well made?
Yes, please.
Okay. So, okay. I will need a point. Okay, that point has been given. Okay, I will need a gradient. So my gradient of the tangent, this is the gradient of the tangent. But I know my gradient of the tangent, but I know that my m will be equal to dy dx, the gradient of the curve at that point. Point well made.
Yes, please.
My professor, should I come again?
Yes, sir.
Okay. All right.
Yes,
So the question is asking you to find equations of tangent and normal. You know, tangent is a line, normal is a line. So I've told you anytime you're asked to find equation of a line, quote the formula and let the formula guide you. So I'm not going to deviate from that. So I've extracted the information. Okay, even if we are dealing with a normal one where you are giving the gradients and what have you, extract the information, then you come and quote the formula and the formula will guide you. So equation of tangent, I've extracted my information that I will need or I've been given. Then equation of tangent, I quote the formula, your usual equation of a line formula. Okay, y minus y is equal to the, and even where we are coming from. Okay, we've stated that one there. So now you quote it. After quoting it, remember when you quote formula, listen to the formula, go and look for the parameters that you need to find in the formula. Okay, then you'll be too good to go. So in this formula, I will need my x sub 1, y sub 1, but that will always be the point, okay, on the line. And remember, okay, the tangent, if you had drawn the tangent to that particular curve, okay, at that point, it will be this. So this point will be on the tangent. So it's on the line, okay, our tangent line. Take note of that. So x sub 1, y sub 1 is what indirectly we are given here. X sub 1, y sub 1. We'll come to that. Then m. So x sub 1, y sub 1 is given directly, but m, which is the gradient, is not given directly. And we know that the gradient of the tangent is the same as the gradient of the curve at that point, which we said is represented by dy dx. So m, which is the gradient, is equal to dy dx. All correct? Hello, are you with me?
Yes, please.
Okay, so we need to go and find dy dx. That's the general gradient function. So this will be equal to dy dx. This is your y. So if I differentiate this, I'm going to get, if I'm finding dy dx, this will give me, here, let's go.
3,
No,
9x,
9,
9x squared,
9x squared, here,
Minus
10x
minus 10x
plus
Plus 3.
plus
plus
3.
3. Okay, so you can say that this is your general gradient. Is that because it depends on x? Are you with me?
Okay.
Okay, so if
Yes.
you want to find that, okay, particular gradient, then you come and substitute the s coordinate of what? Of that point into this. Points well made, my professors.
Yes, please.
Okay, so I will come and write at, okay, x is equal to, or the point 1, 3, x is equal to 1. Is that clear?
Yes, please.
Okay, so your gradient, which is m, or your dy dx will be equal to, let's go, 9 into 1 squared. Do you agree?
Yes,
please.
Minus 10 into 1 plus
Plus
what?
3.
3. All correct.
Yes, please.
Okay, which will give us, let me come and write equal to here. Usually I want to avoid you writing, so this will give us 9, okay, minus 10, which is minus 1, then plus what? 3. So that will give us 2. All correct.
Yes, please.
Okay, so you know the gradient, okay, of the curve at that point, which happens to be the gradient of the tangent at that point on the curve. So it means we know our m, and once we know our m, we are good to go in finding the equation of what? Of what? The tangent. So I can come and write, okay, this implies that I go and substitute because, okay, let me write, it's only 1 point. So this implies that y minus y1. What is your y1? Y1 is the y coordinate of the point. So that will be 3. Is that clear?
Yes, please.
Okay, it's equal to, so now we've gone back to the coordinate geometry 1. Okay, after using differentiation to find your gradient, back to coordinate geometry 1 to find what? Okay, so now let's go. It's equal to your m. What is m? We found out that is 2. All correct.
Yes, please.
Okay, 2 into x minus x1. x1 is what?
1.
1. Very good. Okay, so now we are going to get y minus 3 is equal to, expand, 2x minus what? Minus 2. And remember in coordinate geometry 1, I told you unless otherwise stated, anytime you are asked to find equation of a line, leave it in the form ax plus by plus c is equal to 0. The standard form, everything on one side equated to 0, but making sure you start with the s term, which is the term that must be positive, followed by, okay, these two terms. As for these two terms, they can take any values. So, okay, my s term here is positive. So it means I have to maintain, okay, these two terms here and move these two terms here, yes, and move these two terms here. So in my mind, okay, that is what I'm doing. So I maintain this, which is 2x, and my next term must be the y term. So the y will come here, which will be minus y. Okay, then it will be minus 2 plus 3. So it will be plus 1 is equal to 0. Okay, is the equation. So that's the equation of the normal. I can choose not to write is the equation because this is an equation. So I'm now, sorry, the equation of the tangent, forgive me. We are now going to find the equation of the normal. Is that clear?
Yes, please.
Okay, so now we come to, it's the same question. The fact that you are going to find another quantity doesn't mean you should leave a line. It's the same question. Okay, Prof. Gideon.
This is because we use equation of tangent, so it means that the final answer is taken as tangent.
It's for that of the tangent. Yes. So you can choose not to. You get it?
So please, can you come again?
I said yes, it implies, because you wrote equation of the tangent and you quoted this formula, so it means all that you are doing here is relative to the tangent.
Okay, sir.
Okay, all right. Okay, so now you come to the next one. So equation of what? Which other line are we looking for its equation?
Normal.
Okay, so of normal, of the normal. Okay, so column. If you have space, you continue. Otherwise, you come down. And that will give us what? Y minus y1 is equal to, its gradient will be perpendicular to the gradient of the tangent. So it will be minus 1 over m. Okay, into x minus x1. So here, all your parameters you know. M, you have found it, so you don't go and find it again. This m is the gradient of the tangent. X sub 1, y sub 1 is the same x sub 1, y sub 1. Afa?
Yes, please.
Okay, so this implies that we go and substitute and do our simplification. Y minus y1, y1 is 3. Okay, is equal to minus 1 over m. M is what? 2, give us 2. Are you with me?
Yes,
Yeah.
please.
Okay, into
Yes,
x minus x1. x1 is what? 1.
1.
Okay, so remember, clear the fraction, remove bracket. So I'm going to multiply through by 2. So that will be this 1 times 2 will give me 2y, times 2 will give me minus 6. Okay, it's equal to this times 2, I will get minus 1, I will write a 1, then x minus 1. All correct.
Yes,
Yes.
please.
Okay, Prof. Carol.
Please, I have a question.
Okay.
Sir, please, the at x is equal to 1, like to the other side or your left, like the bottom there. So
Yeah.
leave x subscript 1 because you only wrote x is equal to 1.
Okay. All right. Okay. So this is
So I'm
it.
a little confused.
No, I have not forgotten anything. It's just a implication. You know that when you are dealing with, what do you call it, the gradient. Okay, the point that you are giving there, you take it to be x and what and y. You are dealing with a gradient. I hope you are with me. Not x1, y1. But when you are dealing with an equation, the first point given will be, or the point given will be labeled as x1, y1. You get it?
Yes.
Okay, so in terms of finding the gradient, this is what x, this is y. In terms of finding what the equation, and you are picking a point on the line, this x now becomes x sub 1, y sub 1, like the way we were dealing with. You get it from the formula?
Yes, please.
Okay, all right.
Thank
Okay,
you.
so now what do we do? Okay, we come and expand the side. Someone could have moved from here to the step that I'm going to write straight away, meaning you could have cleared the fraction, then remove the brackets, okay, together. So minus x, okay, plus 1. Okay, so remember, our form of the equation must have everything on one side equated to 0, unless otherwise stated. Sometimes specifically you'll be told to leave it in the form y is equal to mx plus c. So in that case, you have to make y the subject. I mean, take it to the gradient intercept form. Okay, here we are not asked to take it any other form. So the standard form all the way. So the standard form, everything on one side equated to 0, making sure that your x term, which is your first term, okay, is positive. So this x term is negative. So it means I have to move these two terms to the side. So you always use the x term, the sign, to make the determination as to where to do your movement. So if I move the x here, I'm now going to get my final equation. If I move, I'm going to get minus x here to give me x. Do you agree?
Yes, please.
Okay, my next term is supposed to be the y term. Y term, this will come and meet it here. It will still remain. I'm not moving. It will remain here as positive 2y. Is that clear?
Yes, please.
Okay, then my constant term, this will remain here, minus s. This one will come here. So it will be minus s minus 1. So minus 7. Do you agree? And we moved everything here to this side. So this side will be left with 0. So 0 is the equation, or is the equation of the normal. But because you've stated normal here, we know that you are finding the equation of Afa.
Yes, please.
Okay, so that will be it for this meeting. So the next one I think is basically the same thing. So in our next meeting, maybe we'll look at how to deal with the rest. I wanted to introduce you to this, so that in our next meeting, we'll see how best we can continue from there. All right, and write our test as well. So please take note. Okay, so any questions at this point before I finally bring the curtains down? My professors, any questions? No questions, I guess. I will take your silence to mean, no questions. All right. Okay, so on that note, then it means I can bring, the curtains down, but please don't leave. All right. So thank you very much for your time and making the class very interactive. May the good Lord continue to bless us. Okay, bye-bye.